Alright, let's look at question 2. There are initially 7,000 bacteria in a petri dish. An antibiotic has been introduced and a third of the bacteria dies every hour. What function would you use to model the above behavior? Okay, so I'm going to use the same strategy. First, I Googled it, and I clicked on the first thing that seemed to resemble a decent answer. And I looked here, and it's not exactly the same question, but it does say, in a laboratory experiment, researchers established a colony of 100 bacteria and monitors growth. The colony triples its growth. So this is kind of the same thing, and this section was all about exponential growth. Just to reinforce that point, right here, right here, I pulled it from this section right here. Okay, so it is a section on exponential growth. So it does seem to be about exponential growth, but what else confirms that it's exponential growth? And that's if you graph it, right? It's a third of the population. So if you think about if it's a third of a third of a third of a third of a third, it's going to gradually disseminate to nothing at all, right? The one thing this one is very tricky is that the exponent has to be negative, right? It's 2 to the negative x because it has to go down. Because if you just graph it normally, the function does, like if you graph the y equals 2 to the x, that function actually tends to go up like so. So that's exponential growth. This is actually known as something called exponential decay. So this is a little tricky, but again, it's a half of a half of a half of a half. So that's exponential decay. By the way, this is not the actual graph of what was going on. I just randomly graphed a negative function, but it has the same effect no matter what it is. So hopefully that makes sense, and I'll see you in the next video.